We're all thinking about AI, right? It's everywhere, and it brings up these huge, huge questions. But what if the most important question isn't really about the machines at all? What if it's about, well, intelligence itself? Let's get into it. Because what if the story we're seeing unfold with AI is actually the same story life has been telling for billions of years?
So let's be honest. When you talk to one of these new AIs, doesn't it feel weird? Kind of alien. It's this feeling that we're dealing with a totally new kind of mind, something that's just shown up on our planet. And yeah, that's a little unsettling, but it's also pretty fascinating, right?
And you know, it's not just us regular folks who feel this way. Just 10 years ago, an AI researcher at Google named Blaise Aguirre-Yarcas, and his work is the basis for what we're talking about today, he felt the exact same way. He's a top guy in the field, and even he was convinced that, for an AI to really be intelligent, we'd need some massive new scientific breakthrough, something from neuroscience probably. He thought a simple next word predictor could never truly get.
Well, turns out he was wrong, and he's the first to admit it, because then everything changed. As these models got bigger and bigger, they just started doing things nobody thought they could. They were understanding concepts, telling jokes, even arguing logically. And the big takeaway, the kind of humbling conclusion, was that the breakthrough wasn't some fancy new idea. It was just scale, pure computational scale. And that right there, that's the big idea we're going to unpack. I mean, think about it. If you can create intelligence just by scaling up a bunch of simple computer parts, what does that imply about us, about all life? Could it be that the amazing intelligence we see all around us in nature, our own included, is actually the result of the very same principle? Okay, so to really get to the bottom of this, we've got to take a fresh look at the story of evolution. We all have the basic picture in our heads, but what if there's this other super powerful creative force that we've kind of been overlooking? Right, so the version of evolution we all learned about is pretty much Darwin 101. It's all about competition, right? A constant, slow grind of mutation and selection. It's a zero-sum game optimizing a species for one specific environment. But what if that's only half the story? What if there's this other process? One that's not about slowly getting better at one thing, but about making these huge creative leaps forward by cooperating and merging things together.
And this process actually has a name. It's called symbiogenesis, and it's exactly what it sounds like. Independent things, we're talking cells, organisms, whatever, they merge together and boom, they form a brand new, way more complex super entity. We're not talking about a small change here. This is a total game changer, a massive creative leap.
And here's the really crucial part. This isn't just a sideshow. This is what gives evolution its direction. It's the arrow of time pointing from simple to complex. Think of it like this. Regular evolution is like fine-tuning a car engine. But symbiogenesis, that's the force that builds the car in the first place. It's the engine of creation.
All right, let's talk about some of these great mergers. Because once you know what to look for, you start seeing this pattern everywhere. The whole history of life is basically just one epic merger after another. So, about 4 billion years ago, you've got non-living chemicals just coming together to spark life. Fast forward 2 billion years, and simple little cells merge to create the complex cells that make up, every plant and animal. Then 1 billion years ago, those cells team up to create multicellular organisms. And way more recently, individual animals start merging into social groups, into societies. See the pattern? Each step is a huge symbiogenetic jump. So that first massive leap, it's the origin of life itself. It wasn't one thing slowly evolving. It was a whole bunch of non-living bits and pieces coming together to create something totally new, something alive, a kind of primordial superorganism. And the next big merger? That's when single cells decided to stop going it alone and joined forces. They formed a cooperative, a collective, and what do you get? You get something like this octopus. An organism with this much complexity, this much intelligence. There's just no way a single cell could ever pull that off.
And that, of course, brings us to us, you and me, humans. We are the ultimate social superorganism. One-on-one, we're not all that different from our primate cousins, but put us together, with language, with culture, we achieve things that are literally superhuman. We build skyscrapers, we transplant hearts, we walk on the moon. Our real power isn't individual, it's collective. And the price for all this collective brain power, it is absolutely staggering. Our brains are just energy hogs. Get this, in a small child, their brain uses almost 50% of all the calories they consume. 50%. That is an unbelievable evolutionary investment in hardware that lets us cooperate. Okay, so we've got this incredible pattern driving all of biology. But this is where things get really wild, because that exact same pattern is now happening all over again in our technology. Think about Moore's Law, right? For decades, the name of the game was speed. Just make a single processor go faster and faster and faster. But then, around 2006, we hit a wall. It just got too hard. So to keep getting more powerful computers, the whole industry had to change tactics. They stopped trying to make one thing super fast and instead started adding more and more cores to work in parallel. Does that sound at all familiar? It absolutely should, because nature cracked this code eons ago. On the one hand, you've got the brain, this insane network of billions of neurons all firing in parallel. And on the other, you've got the chips that run modern AI, with their massively parallel design. It's the same idea. We didn't invent parallel processing, we just rediscovered it in silicon.
So let's just call it what it is: technological symbiogenesis. This means AI isn't some weird alien thing that just dropped out of the sky. No way. It's the result of the very same process that made us, merging a whole bunch of simple parts, having them work together in parallel, and creating a new, intelligent whole.
So, okay, if this is the right way to think about it, what does that mean for our future? Well, it completely changes the conversation, doesn't it? It stops being about fear and starts being about coevolution.
Usually the debate is framed as a fight, a zero-sum game. AI is the scary competitor. It's going to take our jobs. It's going to take over. But this other view, the symbiogenetic path, it offers a totally different future. One where AI isn't a competitor, but a new partner. The next big merger, leading to a new kind of human-machine intelligence that can do things we can't even dream of right now.
And really, that's the choice in front of us. Do we see AI as this alien other and head down a path of conflict? Or do we see it as part of the same grand evolutionary story we're already in and choose a future of cooperation and creation?
Because here's the kicker: this merger, it isn't something that's going to happen. It's already here. We are already living in a hybrid world. Our entire global society is a giant mix of biology and technology, completely dependent on each other. AI isn't the start of something new. It's just the latest piece to click into place.
So maybe, just maybe, we've been asking the wrong question this whole time. It's not us versus them. It never was. The real question is, as we continue down this ancient evolutionary road, merging with the very technology we've built, what are we all about to become together?